have some highlighters because I'm going to try to make things stand out a bit for you. Okay, so we're going to talk about conditional statements. And the first giveaway that you're working with conditional statements is if you see a statement that has if, and then at some point in the sentence it has then. Okay, it starts with if, and then you'll see a then somewhere halfway through the sentence. And that's what we call the original conditional statement. Okay? So, this statement says, if today is Wednesday, then yesterday was Tuesday. That's the conclusion. Okay? And again, it starts with if, and then all of a sudden you have a then appearing, right? Whatever follows the if is what we call the hypothesis, and the letter P is given to it. Okay? That's just universally, that was P. Whatever follows the then is what we call the conclusion. Okay? The arrow is then. That's what we know as then. Okay? So, this is what I, for now, want you to remember. The original conditional statement says if P, then Q. Right? It's weird, I know. If you've been in computer science, if you've done coding, this will maybe make a little bit more sense to you. But this is what I'm going to start with. Okay, this is our original statement. I use something that you can relate to. Because if today is Wednesday, then yesterday was Tuesday. That's true, right? Like you can't deny that. Next. In order to determine the veracity, the validity, I'm gonna add that word, of the original statement, we dig a little deeper based on the original. Okay, so we have converse, inverse, contrapositive, and biconditional. And you don't need to memorize this, you just have to have it on your study sheet. And you're scratching your head maybe a little bit. But the converse is essentially when you flip the hypothesis and the conclusion. Okay? So look at this, the notation kind of gives it away. Earlier we had P, then Q. If you flip it, you're going to say if Q, then P. Right? So let's rewrite that. We would say if yesterday was Tuesday, what are you going to say then? Then today is Wednesday. And in this case, you don't need to make any changes. Sometimes you have to change some words slightly for the statement to actually make sense. But in this case, we could just replace it perfectly. So this part right here is Q from our original conditional, and this part right here is P. Okay, so we just flipped it. It's the converse. So when somebody says the converse is also true, is when you flip the statement like that. Okay, next. Inverse statements, that's the next one, in no particular order. We are basically negating the hypothesis and the conclusion of the original. To negate, we simply add the word not in front of the P and the Q. And here's where it gets complicated, okay? I asked the province and they said you can expect any one of them. So watch this. You might think it's overwhelming. Anytime you have like a line or something next to P, that means not. Okay, it's just bottom line. So all of these three are saying the same thing. I'm going to stick with this one right here. I'm going to just stick with that. with putting the bar on top. So this is saying, if not P, then not Q. That's what that is saying. So let's do that. We go back to the original, guys. And here you have to do a little bit of English manipulation here. If it is not Wednesday, Mr. Dixon, what if I said if today is not Wednesday, is that also okay? Yes. So you can massage it a little bit, right? If it is not Wednesday today, then yesterday was not Tuesday. Tuesday, capital, come on. See, I'm not going to mark any grammatical errors on this one. If it's sort of right, then it's good enough, okay? So if it is not Wednesday, so this is in front of P, right? And then it's not, then yesterday was not Tuesday. Okay. Contrapositive. Contrapositive is when you flip and you negate. So you're basically turning it into converse, and then you're negating both. So it's kind of like a mix between converse and inverse. And I'm going to stick with this format right here, even though all three are saying the same thing. So you should be able to just look at this letter, and you've determined up there what's Q. Whatever follows then is your Q. So what would we say here? If yesterday was not Tuesday, then today is not Wednesday. So remember, this used to be P, right? In the original, P was up front. It followed the if. Now we put it here, and that's why you can see P is on the right side. And whatever used to be Q is now up front. That's why Q is up front. And then the nots, we knew we had to put them in because of that. Okay, the little bars on top. So if yesterday was not Tuesday, then today is not Wednesday. Okay? Okay, biconditional, last one. Last one that you have to know. Biconditional. Substitute the word if and only if. The statement is only true. Okay, this is important to highlight. The statement is only true if the original and the converse are actually true. And highlight this with a different color. There's no counter examples that we can find. There's no contradiction to the statement that we can possibly find. So, watch this. What's up with the notation here? What do you notice about the notation? Arrowheads go both ways, right? That's how you know that's a biconditional statement. So watch how you do this one. You go back to the original. P is first, so today is Wednesday. If and only if. That is the new part, right? If and only if yesterday was Tuesday. And now I'm just going to make sure you understand this part when you go back through your notes. Let's make sure we understand that this here is not P, okay, and this part right here is not Q. Same with contrapositive. This part is not Q, and whatever follows the then, right, it's not P. When is P and Q determined? Like, when do we determine what P and Q is? From the very initial conditional statement. Whatever follows the if at the very beginning is P. Whatever follows the then is Q. My head is hurting, right? And so this is a basic thing that I would expect you, and the province would expect you to do. I should be able to give you this statement, and you turn it into either an inverse, a converse, inverse, or contrapositive biconditional. You should be able to just rewrite it. That's a basic expectation, okay? So here's where it all gets summarized. Go to 48. So to turn a statement into a conditional, you got to go if then. I don't know if you need this part on your study sheet. I don't think you, after practicing a couple, you shouldn't. I would just have conditional, then that. Converse is flipping, right? You flip the P and the Q. Okay? Inverse is not P, not Q. Contrapositive, not Q, then not P. Biconditional is double arrow like that. What I would add to my note, to my study sheet, is the under biconditional, you go if and only if, because that's different, right? You need to add that statement. And maybe next to conditional, you just remind yourself that the if and then needs to be there. If you don't have if and then, you lose marks right away, not even a chance. Okay, so you need to have the if then if they ask you to turn something into a conditional statement. Fun stuff, eh? Let's practice one more time. And then the rest I'll let you try. Write the following statements in these different forms. Let's remind ourselves real quick. Converse is Q, then P. Inverse is when you negate like the original. Contrapositive, not Q, not P. Biconditional is if and only if. Whenever you see the word con, it means switch. Contrapositive, converse, right? You're flipping for sure. Except for contrapositive, you're also negating, right? So that's a bit different, but con means switch right away. So converse, first of all, let's figure out what P and Q is. If Sandra cleans her room, so that's P, then Sandra's mom will not get upset. So now we've determined originally what P and Q is. Let me just bring this up. Okay. So let's rewrite it. What would be the converse of this conditional statement? We would say if Sandra's mom does not get upset, doesn't get upset, then Sandra cleans her room. Close enough. Okay, we understand that you see that we need to flip the statement, and so that would be good enough. Okay. Inverse. Please always go back to your original when you're rewriting. Don't base it on the previous, right? Inverse. It means to negate the first part and negate the second part. So we will say, if Sandra doesn't clean her room, then, 1 second. What do you say? What do you say if then Sandra's mom will not get upset? Isn't that weird? Technically, you'd be okay to do that. But if you say not, then you're actually saying that you will clean your room. Like if you say, I will not do this, then you're actually saying that you are going to do it. Like it's almost like a double negative. What happens when you have a negative in math? Positive, same thing. Don't be too alarmed with this. I just thought I would throw it in the mix if it ever happens. So then the mom gets upset. Then mom gets upset. We'll just say it that way. Contrapositive. Yeah.
When we say if Sandra doesn't clean the room, is it okay if we just say doesn't, or do we have to say does not?
You can do either one. Yeah, it's not English. In English class, it probably give you half a mark off, right? Yeah, it doesn't matter here. Close enough is good enough. Yeah. Basically, we're just trying to see this. Do you understand what needs to happen here? If we see you flipping, yeah, stop flipping. Then we're fine. If you say not, doesn't, whatever, we understand that you need to negate, okay? Contrapositive. You flip and you negate. So we'll take this. If Sandra's mom, what are we going to say here? Does not get upset. That's, if you like that, go for it. But if Sandra's mom gets upset, I don't know, I feel like I need to add this for your notes. Not times not is yes. See, right? Next time your parents like, I don't want you to stay up too late. I will not stay up too late, Mom. And then you're really saying, I will stay up too late. Right? But they'll be like, huh? Right? If Sandra's mom gets upset, comma, then make sure you have the if and the then. Absolutely. Then Sandra does not clean her room. Yikes. Note to myself, bigger box. Okay. And the biconditional. You go back to the original, you say Sandra, you drop the if at the beginning. Sandra cleans her room if and only if Mom does not get upset, will not get upset. Okay. I will leave the rest up to you. So I have, I think 40, it goes to 49. So try 48 to 49. We're not done yet though. Say what? One thing I want to tell you, logically, and that I want to go back to the chart up top. If you're copying this, I'm just gonna tell you to go back here. The conditional and the contrapositive are logically equivalent. You are saying the same thing logically. It just sounds different, but really you are saying the same thing. So I will do this. Equivalent, right? logically equivalent. If you want to say they're the same thing, they're saying the same thing, you're fine. And just make sure you understand it's the contrapositive and the conditional that are logically equivalent. Okay, truth tables. Truth be told. So for tomorrow, know how to just rewrite statements, okay? Let's go to 50 here. Checking for veracity whether or not a statement is true. Just because something is phrased in an if-then statement does not make it true. For example, consider the following statement. If an animal is a bird, then it can fly. Is that true always? Ostrich, right? If a statement is false, this is important. A statement is false if the hypothesis is true, P is true, right? But the conclusion is false. More on this later, right? If the first part is true, but the second part is false, you've lied. The statement is not valid, okay? So that's when we arrive, so we need to prove it false. You just need one counterexample. That's where the hypothesis is true and the conclusion is false. Like you gotta, if the question ever asks you, give me a counterexample, there is one. You just have to find it if they say it like that. If they say, hey, do you think the statement is always true? Justify. So you just need to find one counterexample and then the whole thing is false. You can no longer say that statement, right? So an ostrich is a counterexample. It is a bird, but it cannot fly. Other examples could be a penguin, emu, turkey, and the list, there's more, right? But there are some counterexamples. This is probably the most important statement right here. No number of positive examples can prove that a statement is true. Like you can have 1,000 examples where this statement would have been true. As soon as you have one counterexample, it is enough to prove that statement false. You just need one counterexample and the whole thing goes down the drain, okay? You can technically no longer use that statement. You should scratch it from your essay. If you're writing an essay with that statement, you should not be using it anymore. So consider the following statement. If a number is prime, then it is odd. Is this true? These are your prime numbers, by the way. If so, how do you know? If not, give a counterexample. Okay? You would say, not true, since 2 is a prime. 2 is a prime, so you're actually saying the first part is true. 2 is a prime, but the second part is not. But it is not odd. Okay? So that would be your counterexample. To what? Sorry. Thank you. Is not odd. Okay? Conditional statements are very important in mathematics. They form the foundation of a lot of theorems that we just take for granted, right? Let's see here. For each statement, try to find a counterexample, then state this if the statement is true or false. If a number is even, then it's divisible by 4. Not always true. Jamie's like, right? So for example, 6 is even, but not divisible by 4. Therefore, not true. If today's the last day of classes, then tomorrow's Saturday. Is that always true? It could be that it's Friday in service. So Thursday would be the last day of classes this week. So the next day is Friday, right? So that would not always be true. Not always true. Counterexample would be a week where Friday is an in-service. You can say it could be a week where Friday is off. We're not too picky with that. Where Friday is an in-service. And I'm just going to leave it at that. That's good enough. If you live in Winnipeg, then you live in Manitoba. If you live in Winnipeg, anywhere in Winnipeg, you will always be living in Manitoba. There's no counterexample to that one. So this is always true. What about if you live in Manitoba, then you are in Winnipeg. You live in Winnipeg. Is that always true? No. What would be a counterexample? You live in Winkler. You live right anywhere. You live in Thompson. If you live in Thompson, you're not in Winnipeg, right? So that would not be true. So not true. Give me one counterexample. I will go Thompson. You can go Churchill, right? Churchill, anywhere. Any city that you know, any town you know in Manitoba would be a counterexample as long as it's not in Winnipeg. Okay. I'm going to stop you there. Yes.